Hi everyone, so today what I'd like you to do is you're going to take out your geometry packet, and that's going to be our real focus for the day. So the first thing that we're going to do is you're going to open up to the page that looks like this. And we're going to take a look about how we can fill out some of this page. So when we're talking about 5th grade geometry, we're going to be talking about classifying shapes using a hierarchy. So that's a lot of different words that are going on. So when we're classifying, we're putting them into specific groups. And if we're talking about a hierarchy, we're looking to see where does each shape fit in. So our goal as 5th graders is to be able to describe a shape by its most specific attributes. So when we're looking at this page, we see that there are 4 main ways that shapes are being classified. So the first part, we're going to look up at the top. A polygon is a blank shape with blank or more straight line segments. So this is really important. So a polygon is a closed shape. So we're going to put that in this first blank. And it has to have 3 or more straight line segments. So when we're thinking about a polygon, I wonder why it has to be 3 or more straight line segments. What happens if we only have 2? What happens if we have 1? Well, that's where our first word becomes very important. It has to be a closed shape, which means that all the sides have to fit together so that there's no open gaps. And if we only have 2 sides, there's no way to close a shape. It's just an angle. So it's not a polygon yet. But if we add that third side, it becomes a polygon because the shape can be closed. And it means that we can define it by a more specific name. So if we look, triangle, quadrilateral, and more than 4 sides. We notice that the first way that shapes can be classified is by the number of sides. So I want you to think to yourself, if we have 3 sides, which group is this going to fit into? That's right, a triangle. So over here, a triangle is a shape that has blank sides and blank angles. So if we think about a triangle, we're going to be thinking about a shape that has 3 sides and it also has 3 angles. So what I'd like you to be doing right now is you're going to have this piece of paper out and you're going to be filling it in as we go. So if we're classifying a triangle by sides, there are 3 different types of triangles that we could be talking about. A type of triangle that has all 3 sides that are congruent is going to be called an equilateral triangle. And you might remember that because equi kind of sounds like equal, so it has all 3 equal sides. So we're going to just draw a little example. And that's a pretty close to equilateral side. The next is when we have 2 sides that are congruent. So this type is called an isosceles triangle. So that would look something like this. And if we want to show that sides are equal, we can show that they are equal by putting a little hash mark on the sides that are equal. So that way, if my drawing isn't exactly correct, it's pretty close and people can tell, oh, you meant those to be 2 equal sides. And the last type of triangle that we can classify by its sides is when no sides are congruent. This is called a scalene triangle. And so that would look something like that. No sides are equal on that triangle. The second way that we can classify triangles is by their angles. So if we have a triangle that has one angle that is equal to 90 degrees, that is going to be called a right triangle. And so we can show an example. And remember, if we're showing that it has a right angle, we're going to show it with like a little square in the corner. Our second triangle that can be classified by angles is when all angles are less than 90 degrees. So that is going to be acute, because all of its angles are acute little angles. They're less than 90 degrees. And then if we have a triangle that has one angle that is greater than 90 degrees, that one is going to be called obtuse. And that would be a triangle that could look something like that. So we've got our obtuse angle, and then this one we have 3 acute angles. So if I want to classify a triangle, I can classify it by both its sides and by its angles. So for example, this I could call an acute triangle, or if it's got all of the same length sides, it could be an acute and an equilateral triangle. Our second group of polygons is going to be quadrilateral. And when we hear the word quad, we're going to think 4. So if you think about a quadrant, or I can't think of any other words right this moment, or like a quadruped is an animal that walks on 4 legs. So the first main category is any shape that has 4 sides that's closed is going to be a quadrilateral. If it has no parallel sides, and remember, parallel is when we draw 2 lines that if we kept going in either direction, they would never cross each other. That's going to be called a trapezium. Our second shape is when we have exactly 1 pair of parallel sides. So for example, if I just kept going and going and going on the top line and the bottom line, they would never cross each other. But if I looked at the 2 sides, if I kept extending that, and then I extended this one, they would meet somewhere up here because they would cross and intersect. But the top and the bottom, they would just go on forever and they would never cross each other. So this is called a trapezoid if you have exactly 1 pair of parallel sides. And then we can get a little bit more specific. So we've got a quadrilateral. It has 4 sides. This one has exactly 1 pair of parallel sides. This shape has 2 pairs of parallel sides, and the opposite sides are equal. So we could show this as this side and this side are equal to each other, and this side and this side are equal to each other. The reason why I can't put 1 little hash mark on the other sides is because that would be indicating that they are the same length as my first side. And they're not the same length, so I have to show a different hash mark. So I just do 2 little hash marks to show that these 2 sides are equal and these 2 sides are equal. So if we have 2 pairs of parallel sides, this is going to be called a parallelogram. When we're thinking about parallelograms, we can have more specific parallelograms as well. So in this case, it just has to have two pairs of parallel sides and the opposite sides have to be equal. If we're getting more specific and more special, some parallelograms have to have all four angles are right angles. In that case, if we have two pairs of parallel sides and the opposite sides are equal and it has four right angles, then we call this more specifically a rectangle. So a rectangle can be classified as a rectangle and a parallelogram and a quadrilateral and a polygon because it fits all of the attributes of each of those shapes. But we would call it a rectangle because it specifically fits all of these other components and it has four right angles. This parallelogram could not be classified as a rectangle because it does not have four right angles. So this shape down here has four equal sides, and we can tell this because there's one hash mark on each of the sides. It also has two pairs of parallel sides. This side and this side is parallel, and then this side and this side is parallel. Each of the sides is equal, and the opposite sides are equal. So it fits in the parallelogram, but it also fits a rhombus because all four sides are equal. And then this shape is very recognizable, but it has to fit such a specific set of attributes. It has to have at least three sides. It has to have four sides to be a quadrilateral. It has to have two pairs of parallel sides. The opposite sides have to be equal. It has to have four right angles. It has to have four equal sides. And if it has two pairs of parallel sides and all sides are equal and it has the four right angles, then we can call it a square. So a square is a type of rectangle. A square is a type of rhombus. A square is a type of a parallelogram, and a square is a quadrilateral. But not all quadrilaterals or parallelograms can be classified as squares, which is why we're talking about categorizing shapes. And over here, when we look, this one has no parallel sides. This shape also does not because they intersect. So if I kept going on either of those sides, but it has two pairs of adjacent congruent sides, which means this side and this side are adjacent because they're next to each other. And then I'm going to just go over what they showed just a little bit more easily. So those two sides are the same length, they're adjacent, they're next to each other. And over here, we have two sides that are next to each other and are a different length. So it can't be a rhombus, and it doesn't have any parallel sides, so it can't be a parallelogram, which means this is considered a kite. And then our last category is any polygon that has more than four sides. So a polygon that has 5 sides is a pentagon. A polygon that has 6 sides is a hexagon. If it has 7 sides, it's a septagon. If it has 8 sides, it's an octagon. If it's a 9-sided shape, it's a nonagon. And if it has 10 sides, it's a decagon. So using this chart, what I'd like you to do is you're going to look at pages 2 and 3 today. So I'm going to just put my chart to the side, and we're going to do the first question together. So what I'd like you to do is you're going to try and draw some shapes to see if you can find examples of true or false. So all trapezoids are quadrilaterals. Okay, so I know that a trapezoid is a shape that has exactly one pair of parallel sides. Okay, so I can draw shape that looks like that. Okay, that's a trapezoid. Is it a quadrilateral? Yes, because it has 4 sides. Okay, so let's try again. That has a pair of parallel sides. And when I close it, it also is a quadrilateral. All right, let's try one more. Let's see what happens if we put a long and then not quite as long. Okay, those are mostly parallel. That's still a quadrilateral. Is there any way that I can draw a trapezoid that is not a quadrilateral? No. So are all trapezoids quadrilateral? Yes. So that is a true statement. So what I'd like you to do is you're going to draw examples to try and see if you can find a way that you could make that statement false. And then the next step is going to be to look at page 3. So we're going to make sure that we eliminate responses. So let's look at question 1 on page 3 together. Is a quadrilateral, so we're trying to determine the shape. Blank is a quadrilateral. So I'm going to look through it. Are there any examples of non-quadrilaterals? Nope, so I can't cross any off yet. So we're going to check off. All of those are quadrilaterals. It has 4 angles that are 90 degrees. Does the parallelogram have to have 90 degrees? No. If I look at my example over here, this parallelogram does not have angles that are 90 degrees. So I know it can't be a parallelogram, or I can be more specific than a parallelogram. Does a rectangle have to have angles that are 90 degrees? Yes, so this is a good choice so far. Does a trapezoid have to have 4 angles that are 90 degrees? No, so I can cross that off. Does a square? Yes, so now I've narrowed down my choices between a rectangle and a square. So now I've checked off that. Now I've gotten all of the shapes that don't fit that attribute out of the way. This last part is so important. It has 4 sides of equal length. Does a rectangle have to have 4 sides of equal length? No. So I'm going to cross that off and I'm going to get rid of that, which leaves me with D, a square. Okay, so for classwork today, you're going to finish pages 2 and 3, and then you're going to finish the rest of the Nearpod.